Hi, I'm Andreas.
Hi, I'm Carlos from Lenses.io, and we'll be chatting today about cross-cluster data replication.
Thanks, Carlos. Welcome.
Thank you.
What is cross-cluster replication for Kafka?
So cross-cluster data replication in Kafka is essentially moving data from one Kafka cluster to a different Kafka cluster. So traditionally, data is moved within the same cluster, so you have different solutions for that, like Flink and so on. But the idea here is we would want the data to be moved across two different clusters, which could be different regions or different networks and so on.
So why is this different than just moving data from one cluster to the other?
In terms of data being transferred, it's the same thing, right? So you're reading data from one place and you're just syncing to a different one. The main difference comes from the limitation that you have to be doing it across two clusters. So within the same cluster, there's a few APIs and functionality that are built in. But when you move over to a different cluster, suddenly the support is not right there, right? Kafka was made to work when you read and write from and to the same cluster. There are no built-in APIs to facilitate the transfer of data across two clusters.
What are usually then the use cases for this? What problems do people have so that needs replication?
We've seen quite a few different use cases. Some people will have the more obvious example is disaster recovery. So you're moving data to keep a secondary cluster in place in case the first one goes down or you have some sort of issue with the first one. Another one is when you want to do archiving of data. So you keep a second cluster for archiving or to run some different types of computations that you don't want to affect the first cluster. Mm-hmm. Data sharing as well. Sometimes integrations with different providers can be done through Kafka. So you want to move some data from your internal Kafka to some outside provider. And there's also two more cases. One is you want to have like some production data duplicated into your staging environment so that you can run some tests in that data. You can do some troubleshooting. And then yet another one that we've seen is data migration. Like one of the ones we've seen recently was people migrating from MSK to MSK with express brokers. And so you kind of have to move the data over to a different cluster in order to achieve that.
Is that also the use case that is most used, or is that kind of this from production to staging environment?
So we've seen, I think disaster recovery is maybe one of the ones that we've seen the most. Mm-hmm. So keeping the secondary cluster. Then yes, production to staging, especially if you don't have a lot of restrictions around your data. Like if it's some sort of, we've seen it with like trading data, like when your prices and stuff like that, you can just replicate it because there's no private data associated with it. Yeah, the other one is migration. So we've seen there's still some companies that are kind of migrating from on-prem to the cloud, or I'm migrating to cost-cutting concerns. They're migrating to different providers. That happens quite a lot during the migration that they have to move the data through some sort of solution.
Mm-hmm. And as I understand it, right now this whole process is a bit difficult because there are a few solutions, but nothing is really that advanced, right?
Indeed. We've kind of did a little bit of a study of what solutions there are. So we've kind of found two main approaches to this problem. One of them is to, instead of creating a connection to Kafka, you just go and explore the actual Kafka files in the file system, and you move those over to your new cluster. That works. It kind of forces you into having access to those files. Like if you're using a managed Kafka instance, that is a no-go. This is also a Confluent product, so it kind of limits you there a little bit in terms of what you can and cannot use. So this would be one approach, so use the files themselves. It also gives you one cool benefit, actually, which is to preserve the offsets from source and target, which is quite nice. So a message which is offset 1 in the source would be offset 1 in the target. Mm-hmm. And you're also just moving the raw files, so that's a little bit less networking and kind of things to maintain. The other big, I guess, bag of solutions, what Lens's Kafka-to-Kafka Replicator is also an example of, where you instantiate a consumer that connects to your source cluster, and then you instantiate a producer that connects to the target cluster. And essentially you have data being consumed from one side and produced to the other one. Within this, you usually have solutions that are vendor locked or not vendor locked, like AWS, for instance, allows you to, don't quote me on this, but I think it allows you to choose data from any kind of provider, as long as they allow you to have the Kafka interfaces, but you can only sync to an AWS product.
That would make sense
Yeah.
from their point of view.
And then you also have MirrorMaker, which is I think the only open source alternative to this at the moment. That one, so it will allow it to replicate things. It allows it to do even consumer offsets. So the committed consumer offsets will also be replicated. To me, it's a disadvantage. Some people will think otherwise. It's based on Kafka Connect. So you kind of need to maintain Kafka Connect. If you're already using it, that's probably a low cost, but you need to keep the two, right? So you need to manage MirrorMaker and you need to manage Kafka Connect to run MirrorMaker on.
That's also what I heard about MirrorMaker, that it actually has a lot of overhead just to have the functionality that you want, because you need
exactly. So you have the extra resources, also the extra networking, because the Connect cluster, you'll have to kind of make sure that everything can talk to each other, and you essentially have two layers, right? So you have the Connect layer that you have to manage, and then within that, the MirrorMaker layer that you have to manage. And then we have Kafka-to-Kafka, which is what we've been developing at Lenses. And we built it as simply a JVM application. So it's up to you to decide of how and where to run it. It also connects through the Kafka consumer and producer API. So it should be more or less compatible with any kind of implementation. And we've also packaged as a Docker container, so you can just run it and scale it from Kubernetes or in a Kubernetes cluster.
And you're not locked into, okay, now I have only these sinks.
No, so the sync is defined as like a vanilla Kafka producer, right? So as long as it's something that you can use a Kafka producer to produce to, K2K will work just as well. And you have you can add the libraries you want through the JVM. So that also allows you to support all types of authentication, and we use the libraries that you want to achieve that.
I think you have a demo for us, right?
Yeah,
Prepared
I think so.
something?
So maybe, I guess before we go straight to the demo, I just wanted to show you the configuration that we're using here. So this is what we defined as a Kafka-to-Kafka pipeline. I'm showing you this file just because there's a token, a Lenses token that has to be specified, and just not to leak our internal token. But the basic idea is, as I told you, define a consumer and a producer. And where you can see already here in the text that I'm highlighting are the vanilla Kafka properties that you can find in any documentation of Apache consumer for Kafka. So we just passed these down, so you can specify the bootstrap servers, the authentication, and then we need a consumer group ID. This will be to make sure that all the instances kind of articulate things in the best way to share the load between them. For the target, it's the same thing. So again, you just configure the connection. This could be anything you want. So right here, for instance, we have Express Brokers as the target and just Amazon Managed Kafka as the source. And then the final thing that we allow you to specify is essentially which data, and by which data I mean which topics you want to move from, and how do you want to send them to your target. So for instance, here we define that there is a topic called props, and we want to send it to the target, but we want to add a prefix to it. So it will actually be sent to a topic name k2k.eot.props. So you have this flexibility of doing routing within K2K as well. So you can choose how the data gets transferred. Yeah, that's exactly what we see here. So Lenses allows you to have this view over multiple clusters. So for instance, here we have this cluster, which is called MSK serverless, and we have a topic there, which is props. And so what we're going to do is insert the message. I guess I can make you the key, and I'll be the value. And maybe just put a single message, doesn't matter. And so we insert this into our properties topic. And so at the bottom, we can see here the message. And on the other side, so you can see that we have this MSK Express brokers. This will be the target cluster. And we have a topic called k2k.eot.props. If everything went right, we should see at the bottom here our same value and key propagated. And so what's happening in the middle is that we have this little K2K instance, which is just a container running in Kubernetes, and it kind of bridges the two. So it will read from one side and kind of write to the other. And yeah, that's more or less what K2K does in a nutshell. And how
that means also for everybody, so that when this needs to scale, you're just scaling this through Kubernetes, adding more containers.
So you just add replicas. You'd be bounded by the number of partitions you're replicating. So scaling above that number is pointless because you'll just have idle instances. But scaling up and down is as simple as adding one instance or removing one instance. And then it will adjust it will reassign partitions so that all of them are being replicated at the same time. So we have a Kafka cluster on the left side, and then we have two lenses instances, two K2K instances, and a Kafka cluster on the right side. And our goal is to move data from that topic orders to the topic orders on the right side, just move the data from one cluster to the other. And simplifying here a little bit, but you'd have, as you would with any kind of Kafka consumer, you'd subscribe to a specific topic, and the broker would assign you a set of partitions, will distribute them across the application. So you have one application being assigned partition 1 and the other one being assigned partition 2. And if things go well, you just produce records, you use the transaction, use the idempotence, and you wouldn't have any duplicates. The problem starts with some sort of network connectivity issue happening between one of the instances and the broker. Let's say that the broker can no longer connect to the instance B, so the instance on the bottom. If that were to happen, as far as the broker is concerned, instance B no longer exists. But there's a time window where instance B believes that it can still produce data. This is made worse by the fact that you usually have buffers within the consumers themselves. So there's probably, I don't know, just making it up, but like 20 or 30 megabytes worth of data already in instance B that can be produced even without it having to go back to the cluster. At that point, you'd have the first instance assigned two partitions. It would gladly continue to produce data for partition 2, and then the second instance would also produce that data. You get duplication. We're no longer into exactly one semantic, so that would be a problem. And so the way we kind of addressed this was we had to introduce an internal topic on the target cluster. And we call that topic the assignment topic. And the basic idea of that topic is that instances will kind of use it as a log of ownership of partitions. So if we zoom in on the topic, what we would have at that point would be an initial message saying producer A owns partition 1. So they would announce, I'm now owning partition 1. Producer B would say the same thing. And then once there's a rebalance, all partitions will be revoked and only then reassigned. Because producer A is behaving correctly, you would be saying, I no longer own partition 1. And once he got assigned the two partitions that were now available, it would produce messages saying, I own partition 1 and partition 2. What happens next is the instance will also both be writing to this topic and reading this topic. And so by reading this topic, we can learn what exactly is happening, right? So if you read it, you know that producer A owns partition 1, producer B owns partition 2. And we know then that partition 1 was released and that P1 and P2 were now assigned. But we never really saw a message saying partition 2 was freed at any point, right? And so at that point, the first producer is aware that in order to start producing for the second partition, it has to do something, it has to take some corrective action to make sure that the other instances stopped from ever producing. What we do is actually quite straightforward. So you can see here that the first instance now instantiates a producer B. And what we kind of hinting at here is the producer usually, or you can set it's called a transaction ID, but it's kind of identifier of the producer. And what The behavior that Kafka has is if I instantiate a producer with a given ID after it was already instantiated, the previous one is walled off from ever producing again. And so when we instantiate this producer B, we're essentially fencing off the other producer from ever doing it again. And that will then cause the producer to fail when attempting to write. And essentially, we get a well-behaved group of instances now, right? Because the other one was deleted, and the new one can now safely produce data for both partitions. Yeah, that was it. That's a solution we developed for this. And then it just repeats over and over again, right? So when there's a new assignment, the same thing happens, and over again.
Yeah, because you would want to instantiate the new instances so that you, let's say, rebalance this again, right?
Right. So if you're using like a Kubernetes deployment, what would happen is the second one would fail, a new one would be brought up. That one hopefully would have the necessary connectivity, and now the partitions would be reassigned. If things behaved correctly, they would each get a partition and start producing data. Mm. So it's self-healing in that sense as well.
Yeah, but it's an interesting way of having this assignment topic.
Yeah, so that's it took us a while to get to this strategy. Actually, the hardest part was this instantiating of the second producer, of thinking like maybe we can do this to kind of fence off the other one. Because it's not something, if you're replicating data within the same cluster, you don't need to do any of this because there's an identifier associated with the rebalance. So the second one would try to produce with an old identifier. Mm-hmm. And Kafka itself would say, you're no longer allowed to produce, so stop it. But because here the rebalance and the assigning and the producing happen on different clusters, we kind of had to find this way of implementing that. So we need to keep some track of some state. Easiest way would be to put a topic there, or else the applications have to talk with each other, but that'll be a nightmare on itself. And then the behavior of stopping another instance from producing was also a nice one to discover.
And then I think you had also another topic that was what, schema topic?
Yeah, another problem we had to solve in K2K, which I haven't introduced before, but the K2K not only is able to transfer data, but it also has support for schema replication. So that means the schemas that are present on your source cluster schema repository will also be moved to your target cluster schema repository. And at first glance, you may think that it's just copying the schema over and that's it, but there are actually a little bit more, a couple of points that we had to really make sure work correctly. Mm-hmm. So we have a schema registry on the left side. We want to move the data. We want to move the schema registry to the right side. And let's say in K2K, you'd be streaming data. You'd find a record with the given schema. The first thing you probably do is identify the schema and the subject of that record. And I guess a naive approach would be to say, okay, I'll just move this schema over to the new schema registry. But the problem with doing that is that schema registries actually have the order in which you register things is relevant, right? So for instance, here, notice that I've registered a schema 10, which is version 6. If I now try to register version 1, it might be that the schema registry is going to say, well, this is not backward compatible, or whatever compatibility we have. It might throw an error, and then we can no longer register a version 1. Mm-hmm. The solution for that is quite straightforward. It is rather than moving just that schema, you move the whole subject over. And then you take note that you move the subject over. You don't need to repeat that operation again. And now we solve the issue with having things replicated out of order because it's just a one go. There is a second issue, slightly different set of images now, but we have something very similar. So we have a schema registry on the left. We want to move things over to the schema registry on the right. The difference now is we're taking into consideration the actual payloads themselves. And one of the issues is if you're using, of course, you can use whatever format you want, but one of the main formats people use is this one where the schema identifier is encoded as a prefix to your binary payload. So for instance, here in the bottom, we can see that there's a payload, and the way to get the schema for it is by looking at that prefix. So the message would be, I think it's 4 bytes. You'd have a 5 there, and then you'd have a payload. And then what you do is you take that identifier, you resolve it in the schema registry, you get the definition, and then you can deserialize a record. The problem is, so before I showed you things as if the schema identifiers were stable when you move them over to the new schema registry, but that is not true. And so depending on the state of the target schema registry, it might happen that a schema that had identifier 5 is now identifier 1. What that means is if we just copy the raw payload, you'd actually have a reference that doesn't reference anything in the best of scenarios, or a completely different schema in the worst scenario. And what we do is essentially the obvious thing, which is we adapt the identifier. So we register the schema, we take note of that mapping, and then we write the message, but with that identifier swapped. And then obviously we take note of that mapping, and that's how we do schema mapping, so that the references in the targets are still relevant and reference the correct schemas. So yeah, so then we correctly copy the payload with a reference updated so that we can reference the correct schema in our target schema registry. And obviously for performance reasons, so that we don't have to keep going to the target, we just keep track of the mapping. So the instance itself will say, okay, I know that schema 5 in the source means schema 1 in the target. So whenever I see a record referencing 5, I'll just swap it to a 1, and only then will I write the record in the target environment.
All right, Carlos, thank you a lot for giving us more insight into Kafka-to-Kafka replication.
Thank you for letting us share our thoughts and our work for the last couple of months on this subject.
Great work. Thanks.
Thank you.